Hello and welcome to another tutorial for the use of SolidWorks. This time we will replicate and simulate a Venturi Flowmeter, and additionally to a parametric study we will review the calibration curve provided by the manufacturer, that is this curve. This to verify the simulation data if the data of the simulation aligns with this curve. It's only to demonstrate the capability of the software to replicate the information here. So let's go here to the workspace of the SolidWorks. And the first we need to do is to select one of the planes of the design tree. For this case, I will select the front plane and select here the sketch option. So now I am in the sketch view. In this case, will be in C view. And we notice now the center point of the sketch is like this. So the first we need to do is to select a line. In this case will be a center line like this one. And in the options of the line, we will select the option that is an infinite length. I will select here an infinite length. And the only thing I need to do is to select the origin point or the center point of the sketch and do it click again. So that will create an infinite line in the sketch. So after to do that, I will select only OK. This one is OK. I will go again in the sketch option, and when it say display delete relations, I will click here in the bottom and select the option that is edit relation. The only thing we need to do is to select the line. In this case, we want the line and the origin point. That would allow us to have a coincidence to the origin point and the line, because we want that line to add a reference point for the creation of the object. So in the select entities, we have the line and the origin point. We will use the option that say coincident like this. Is now say is fully defined, and okay again. Now that we already select that option, the only thing we need to do is go again to center line, create a construction line like this one. I will put it here, another to this point. Don't worry about the dimension because we will use the smart dimension option to modify the dimension. So after we have the two lines here, I will use now a simple line and create something like this. A line here, now a line with an angle here, another here, again an angle, and after connect with this line. So we will have something like this. This is like the preview of the Venturi Flowmeter. Now we will go again to smart dimension options, and the first we need to do is to select the origin point here, and one of the points in this line. I will select this one, for example, and I have to get the verification that we have to select the distance between the origin point and the other point. So I said that the length will be this. I will change to 7 millimeters. Now I have something like this. And I will modify the length in these three lines. So I will modify first the length here. Try to do in this order, because if you don't do that, you will have some mistakes in the creation of the object. So try to do in this order. So select the first the line in the left. It will be 24. After the line in the middle, it will be 14. And finally, the right line, it will be also 24. Now that we already set the value of the three lines, I will set the value of the angle here. So I will select this line and this one. And now I will put that here is 10.5 degrees. Now with the other here, this one will be 7. Now we will select the distance between the origin point and this line. So I will select this one and this one. This will be 7. And finally, the distance in these 2 points. So that will be 12. And also you will have 12. Don't worry about which the line modified to increase the dimension of the Venturi. That we want, sorry. And you will have something now like this. The values of the line here will be 12, 12 here, 24, 14, 24 here. And here, like in the angle of the line, we have in this part 10.5 and here 7. So now that we have our creation or the preview of the Venturi, the only thing we need to do is to close the drawing. So to do that, we have to use here the line, select click here and here, and here and here. You need to do that because the software will say that the sketch is open, so I will need to remind that. After we have these options, now we have to go here to features, select the option that is a revolve boss base. For example, the software already say the sketch is currently open. You want to like the sketch to be automatically closed. You have to say yes, and you have to select the axis of revolution. In this case, will be the infinite line that we have here, and you will have a pre-visualization of the revolution. So you will have to expect something like this. So now we need to do is go here in OK. And now we have like the body of the Venturi Flowmeter. You will have something like this. And before we continue to the simulation, the first we need to do is we have to create 2 points that will serve as a pressure device to measure the pressure in the point here in this section and here in the middle. So that will be help us to create the calibration curve using the data of the SolidWorks and compare with the calibration curve from the manufacturer. So the only thing we need to do, for example, here I will select the top plate option, go here to sketch, for example, and I will create 2 circles. The first one will be exactly here in the middle of the section, so it's also in the middle of the sketch. So we will have to see the origin. I will create the first circle there. And the next one will be exactly in the same position respect to the origin, like this. The value will be 2 millimeters of radius or 4 millimeters of diameter. And I will need to verify. Here you have 4, so it's okay. And here we have to change the value to 4. And now the distance will be to the center point, to the center point of the circle, and it will be 46. So now you have something like this. Don't worry about it's in the middle of the sketch. We will create now an instruction to create like um, the devices to measure the pressure. So go here now to features, extruded boss base, and for example, if you can use the blind option. For example, here I will put it like this to the other way, and I will put maybe like this 15. Don't worry about if the instruction cross the solid, because for this point we only have a solid piece, so it will merge together. So also we have the merge result here. So the only thing we need to do is go here to OK, and now we have an model like this. If you want to verify that the merge is okay, so you can use the section option view here, section view, use the section view, and now you have verified that is only a solid piece. We have nothing there. And now we have to create the Venturi Flowmeter. To do that, we will use the option that is also in features, the shell option, and it will help us to create the Venturi Flowmeter. So the only thing we need to do is to select the faces that will represent the inlet, the outlet, and the sensors. So I will select this face, the first one, and this one, and to modify the value of the thickness of this shell. So in this case, I will put 1 millimeter because I want to create only a thickness, especially here in this part, because if I put like 2 or 3, it will not work for me. So I will put only 1 millimeter. So I will put 1 millimeter here, select the 4 faces that will represent the inlet and the pressure devices. And I will do okay. And now we can see that the shell option create like a structure that will represent the Venturi Flowmeter. So in the full simulation option, this software will use this structure to create the simulation. So now that we have our Venturi Flowmeter, well, the representation of the structure of the flowmeter, we need to save the object. You put set here, put the name that you want. For example, you put Venturi-2, for example, because I already have one. Save, and now go to the option of flow simulation. If you don't have the option flow simulation, you can go here to the option sections, go here in this bottom, select the add-ins options, and you have to verify that you have select the flow simulation add-ins in the system. So you have to right click here, and also you want that every time you begin the software, it will already have the flow simulation active. So you have to put it here. Now that we're covered that we have this flow simulation, the first we need to do is go here to tool options and create a lead. A lead, it will help us to have like a physical limit to the domain to help the software to create the computational domain that will have the discretization of the system. So use the option create leads. And the only thing you need to do is to select like a planar face that already set here. Select planar face to the openings belong to. So select in this option, this one, this, and this. So we have 4 faces. And you will notice now it's like a blue here that will represent the lead. So now I will select here in OK. Now we have now the leads, but if you want to verify that the Flowmeter is open, or well, is not like a solid piece, go up to the section view. Now it's like we only have the structure or the wall in the Venturi. Now I will start to create. So to create the simulation, first we need to go here to the wizard options. The first one will set the name of the project. You can put the names that you want. For example, I will put Venturi. Some information if you want to put it, some comments. If you don't want to put anything, go here to next. This one will be the unit system of the simulation and also the parameters, the units, and the decimals of the parameters. If you want to modify some of the parameters, you can modify here. If you want to select one. And also, if you want to modify one of the units of the parameters, you can select here the unit and you can change it. So I will put it exactly the same. Also, if you want to modify the decimals, you can modify here. As a recommendation, I will not change anything here. So I will do it next. Here is the most important part of the simulation because it's the physical feature that is already say here. This is the feature that allows to simulate some different conditions. For example, if you want to measure a fluid flow, you have to set this one as a value. If you will have something with conduction, heat transfer, or something with temperature, you have to enable the option that say conduction. If you want your simulation in time dependent, you have to select here, for example, and you can modify the complete analysis time. So put the values you want, for example, 1 hour, you put the value here. If you don't want to time dependent, so it will be in a steady state, don't select the time dependent. If you want the effect of the gravity in the system, put heat as default. You'll always put it in C component. In this case, I will put it in Y. For example, we change here. And you also notice here in the system, you have a arrow pointing to the Y option, well, to the minus of the value. If you have some rotation in the system, and also you have some free surface there. So we'll have nothing of that. Now the other important part of the simulation, this one wizard or this flow simulation works with different analysis styles. The first one will be an external, and is in, for example, here in the figure that is already there, you will see, for example, an sphere that is surrounded like in a flow. That will represent an external analysis. So that means you have an object that is surrounded with a mean, for example, an air or maybe a fluid. The second one, that is this representation, will be a flow, for example, here, that is uh, surrounded by a solid structure or a physical structure. For example, in this case, if you have like a tube, the tube will represent the structure, and the fluid inside, that one. So for this scenario, I will change the analysis type to internal. I can put here exclude cavities without condition, because we'll have some condition of movement. But if you don't have, for example, condition, you have to enable this option. I will put it next. This one is the option, the section when you select the fluid. In this case, for this scenario, we'll select water. If you want to modify or to use another, you can select. And if you want to modify the model about the turbulence, or well, the turbulence model of the system, or if as a laminar flow, you can select it. For example, if you don't know the model, you can use laminar and turbulent, and the software will be designed for you. But if you already know that the simulation is in laminar, only use laminar, or if you already know that it's turbulence, use turbulence. I will put in laminar and turbulence. Here you have some cavitation in the system, or in this case we don't have cavitation. I will do next. This well will represent a condition in the wall that is to the mean, for example. So like this figure represents, this one is the wall, and this is like the, for example, if you have a tube in the middle of the street, that will represent the air, for example. So you can select the different option here. For example, the thermal condition, if you have some heat transfer coefficient or a heat flux or a temperature here, you can change. In this case, I will not put it anything. It will be like an adiabatic. You put next. And here's like the initial condition of the system. So I will not change anything here. So I only have to do is finish. And the first we need to do is like a box here. So this box is the computational domain. As I already mentioned, this is the domain that the software use to create the mesh and also discretize the model and get the results. So you can modify the computational domain. You do like right click here and edit definition. You can modify, but for this scenario, I will not modify the computational domain. And also it will hide because I don't want to see it. And then you will have something like this. Now, the first we need to do is to select the boundary conditions. To do that, we go here to boundary conditions, right click, insert boundary condition. And for this scenario, we'll select inlet velocity. This one, there are three types of boundary conditions. The first one, as already the name saying, is a flow opening. it will be an inlet max flow, max flux, volume flow, velocity, and also outlets. So we will have some outlet max flow, outlet volume flow, and outlet velocity. The second one will be a pressure opening. That means it's an opening to the, for example, the environmental. So, for example, you have a room and you open the window, that window will be a pressure opening. So we have like a environmental pressure. So it's environmental pressure of the system. If you have like an static pressure or a total pressure, you can change and use these options. And the final will be like a wall. So we have two options, a real wall. If you want to modify parameters in the wall, you have to enable the option. For example, you have a wall temperature, also a heat transfer coefficient, or maybe a roughness here in the system. If you don't want anything, you can put it here. That is nothing. Or you can use the option that is like an ideal wall, that the name says is an ideal wall. Is only a wall. It's a physical limitation. You don't have any interactions and any parameters there. So you can use that option. So for this option, you would use the first one, flow opening. Go here to inlet velocity. You also have the different parameters. The first one will be normal to the face. That means we will use like a perpendicular to the face that you select. The second one will be your height, some like a sweep in the system. So I'm moving like this. And finally, you have to put the value in the vectors. So you have to put it in the different components, X, Y, and Z. You can put it here. So I would use the first one. This is normal to the face. I will put the value. This one will be 1 meters per second. And also, I have to select which phase will be that boundary condition. So the first one will be this one, but be careful. If you put click here, it will already select that phase, but that phase doesn't work for the system. I will delete that one. So then the option that I have to use is delete. And to select delete, we have to put your mouse here without click, use the right click. They will display these options and use the option that is like select other. And you have to use the lead that will represent with the name lead, or in this case will be use the imported name. So also you can verify with, because it's like a cube with a circle in the middle. So use that option. So you have to select the option that says imported. Now here, already select the value of the flow opening and the value of the velocity. If you want to put some temperature there, you can also put it here. And some of the turbulence parameters. I will not change anything here. I only use the inlet velocity and the velocity. And I will put it okay. Now I will put the second boundary condition. That will be the outlet of the system. To do, I will do exactly the same. Right click in boundary condition, insert boundary condition. Instead of using a flow opening, I will use the option that is a pressure opening. I will select the first one, environmental pressure, and do exactly the same. Go here to the mouse, right click, select other, import it, and that's it. Then you have to do is that okay. Now, if before continue, we can verify the preview of the conditions of the boundary. And the only thing we need to do is go here to the top in the display option, go here into display, and select the option that is a transparency. With transparency, we will set the value of the transparency in the solid. So if you put it like 0, it will be complete opaque. And if you put it almost to 1 or 1, it will be completely transparent. So now, for example, we put it like 1, and we have like the representation of the boundary. For in the inlet, you have some red arrows that is pointing inside the Venturi. And in the environmental pressure, you have the pressure option. So you will have two arrows in blue that pointing to the inside of the Venturi and also to the outside. And finally, we have to put some surface parameters that will represent the value or the values that we will to measure in the system. So the only thing we need to do is, before to that, sorry, we have to put another boundary conditions. So I will use the section view because I want to select the inside part of the Venturi. So I use the section view. I will add section view like this. Go to boundary conditions. In this case, I will use a wall, a real wall, and I will select the walls inside. So I will select this one, this one, this one, this one, this one, this one, and this one. This only to set to the program that these walls represent that, only a wall. So I will select all these walls, and I will have something like this. Now that you complete to select the walls, now we go here to surface parameters because it's a parameter that will help us to get the value in the simulation. So the first thing we need to do is click here, insert. Don't worry about if the say the results that are currently not loaded. That means because you already not run the simulation. But I will already create the parameters. So I will use the surface parameter. I will select this face as already mentioned, select other, the imported, that is this one, and I will put here that I want the pressure here. So I will put here the first one. I will change the name. I will put pressure A. And I will set a new surface parameters. That will be this one. Right click, select other, imported. Also the pressure, because it's the parameter that I want to get to this section, sorry. This one will be pressure B. And finally, I want a third one that will be this option for this section. Select other, imported. We already set the value of the velocity, but we want the value of uh, the volume flow rate. So instead of you calculate the volume by hand, you already ask the software to give you the volume flow rate in this section. I will select the volume flow rate in this section that is represent the inlet. And here we'll change the value, volume flow. Now, usually if you want to get the value, you have to run the simulation. Go here to run, and you will run the simulation, and you will get a value. But for this scenario, we have different cases or different scenarios. So instead of create each simulation separately, we will use an option that will say like a parametric story. That means we will give all the values that we want, and the software will create all the different simulation or the different scenarios in one run. So to do that, we go here to the Venturi options, right click, and select new parametric story. When you do that, you now have a new window, or that will be a what if analysis. And you have some input variables, output variables, of course, the scenarios. So the first we need to do is go here in input variables, edit a simulation parameter. So click here in this bottom. You will have some parameters here. In this case will be, for example, the boundary conditions. And we will select the boundary condition. In this case will be only the velocity. So we will select the velocity. In this case will be the velocity normal to the face. And put it here in OK. And now you will notice here that you already have the parameters that you select, the value that we already select in the boundary conditions. And this one will be how different scenarios we have. In this case, only we have one. So to put more scenarios, the only thing we need to do is double click here. You will notice here now here a new window, and here you have to put the different scenarios. So in this case will be 10, 7, 5, 2.5, and let me verify the others. 2.5, 2. We already have 1, so it will be 0.575, 0.5, 0.25, and finally 0.1. So now we have 10 values, or in this case 10 different scenarios for the simulation. So I will put it only here in OK. And now, for example, here you have now the values. It will be 1, 10, 7, 5, 2.5, 2, and etc. So after you complete to do that, go here to output parameters. You will select the the add results, and in this case you have to select the result option. In this case, because we not run simulation already, but we already create the surface parameters, we have to select the parameters we want to study. So we have to select the pressure A, the pressure B, and the volume flow. That will simulate the parameters for each scenario. So we will have the pressure A and B and the volume flow for the 1 meters per second, 10 meters per second, etc. So select the 3 surface parameters, pressure A, pressure B, and volume flow. Put it here in OK. Also, we have the scenarios here, the pressure A, pressure B, and the volume flow. And the only thing we need to do is click here and run a study. And now, instead of you have to run by manual each scenario, the software will create each scenario in a complete run. So, for example, he is already finished in the first scenario in 1 meters per second. Now it's in the second one, 10 meters per second. Now it's in 7. So it will be easy for you to create a simulation with different scenarios at the same time. So instead of create that one manual, or you have to change the value by manual, you can put it like an automatic form. Or in this case will be a what if analysis or a parametric study. So the only thing we need to do is to wait to the simulation to finish. So now, for example, the simulation is already finished. If you want to verify the value, you go here to the pressure A, and now we have the values of the pressure, for example, here in 1 meters per second, 10 meters per second, 3 meters per second, 5, etc. If the pressure A, you already have the values, and the volume flow. So you have the different values of the simulation. And now, if you want to modify these values, you can copy this information or already export this value to the Excel. So the next part that we're going to do is to copy this information to an Excel. So let's go. Now, for example, here I'm here now in the Excel and already copy the value of the information of the SolidWorks. For example, here in the scenario, the pressure A of the 10 millimeters, I already put here the value of the. Also, we have to verify that this one you have to put the average value, because you have the minimum, the maximum, and the average. So try to use the average value for each pressure, and also the average value for the volume flow. So you have only need to do is to copy the value of the pressure A, the pressure B, calculate the pressure drop option, convert that value to Pascal to meters for water because it's the value that the manufacturer gives us in the curve. So it will be meters water to flow rate liters per second. Also, we have to do that in the volume flow because in the volume flow rate we have meters, square meters per second, this value, and we have to convert. So we'll convert that one to decimeters, cubic decimeters per second. So it's the same as liters per second. And now we have this value. So now that we already create our table with the value of the pressure V, A, and the volume flow rate, the only need to do is to create a curve. This one is the calibration curve that the manufacturer gives us. And the only thing we need to do is to create our curve using the data here. So go to insert and graph, select the first one, for example, this one, and after you complete to do that, go to select data, edit, the name, don't worry about the name, you can put something like this. The values in X will be the flow rate, so that will be this one. I would use only these values because that will be graded at the values that is in here in the calibration group. So you only use the values to 2.5 to 0.1. So use the values that is in blue color, for example. And the values in white, so that will be the pressure. So I will use this option and I will have something like this. And the only thing I need to do, for example, here I will erase this option. I would modify the design in the graph. For example, here I will use like this without color here. The values of the markers I will use here. I will put it a big marker. I will change the color, for example, here in red. Also here in red. I will change some of the data here to help me to compare this my curve created with the simulation data with the calibration curve. So after I complete this one, I only need to do is to move my curve and try to get the values in the same position as the calibration curve. For example, I will put this 0.2 that is exactly coincidence with the value of 0.2 here in the, for example, here now I have the 0.2 here and it's in the 0.2 of the calibration curve, 0.4, 0.6, 0.8. And now here I will change a little bit. I would put it the 2 with the 2 of the pressure of meters per water. So maybe this one you have to do it by hand, but it will not take so much time. So it's only to get the values of the markers exactly as the same of the calibration curve. So after you complete that, you can verify that the values of the data that you get to the SolidWorks is almost the same as the calibration curve that it gives for the manufacturer of the device. So you can conclude that the SolidWorks flow simulation will help to compare and corroborate the information for the simulation, for example, in this case, for experimental data or a calibration curve given for the manufacturer. And finally, if you want to do something more in the simulation, maybe here if you don't want to close, I will create, for example, here some flow trajectories. So I will select the flow trajectory option, insert. I will select this, the imported phase. Here I will change the number of points, so that will be more points to create animation. And only do here. Oh, sorry, that occurred because we have to run the simulation like an standalone option, so I will have to run again. I already run here. Now I can create the flow trajectory option. Maybe instead of using arrows, maybe I will use line and arrows. And now I can see the movement of the flow inside the Venturi. For example, that is the pressure option. Instead of view the pressure, maybe I want to view the velocity. And now, for example, we can see that in the reduction of the Venturi, we can view the increase of velocity inside the simulation. If you want to maybe use a cut plot option, go here to cut plot, insert. I will insert maybe a cut plot here in the front plane. Also maybe in velocity. And I have something like this. If you want to be clearly this image, I go here to display, lighting option, and now you can see like the image is more clear. It's clearly solid. And now we have something like this. Well, instead of using, for example, here the velocity, in the control, maybe I put the pressure option. And now we have something like this. So we can use these results to compare and also to observe the behavior inside the Venturi Flowmeter. And also to verify the data given for the simulation to compare to a calibration given for the manufacturer. So thank you to watch this tutorial and see you in the next one.